I get that feeling, like, the line between science fiction and reality is getting kind of blurry.
Yeah, definitely.
Today, we are diving into something that I think really captures that feeling. Recurrent neural networks.
RNNs.
RNNs, yeah. So imagine like a computer program that can kind of write itself.
It's learning these patterns, these structures in data. And it figures it out in a way that, honestly, would take us humans like a really long time to even start to pick up on.
Okay, so when you say data, are we talking like spreadsheets and numbers, or is this something a little different?
It can be that kind of data, but what RNNs are really good at is sequences. So anything you can think of as a sequence, an RNN can try to make sense of.
So instead of just looking at a single picture, it's like the RNN is watching a whole movie, understanding how each scene flows into the next.
Exactly. That's what sets RNNs apart from those more traditional neural networks, is how they can predict the next word you're going to type or understand the trends in, let's say, stock market data. I mean, people are even using them to compose music.
Right. And that's where I think Andreas Karpathy's blog comes in. He calls it the unreasonable effectiveness of RNNs.
And he's not wrong.
No.
Oh.
And to prove his point, he shows all these crazy examples. Like, he starts with this basic idea, training an RNN to predict the next character in a sequence, almost like teaching it to spell.
Yeah, it's like you show the RNN the letters K-E-L, and then boom, it figures out that the next letter is probably going to be O.
Right.
But here's the thing. It's not just memorizing the word hello. It's actually picking up on the underlying probabilities, the relationships between characters,
Interesting.
which means it can then generate completely new sequences that it's never seen before.
So it's not just spitting back what it's been fed. It's actually learning the rules of the game.
Right.
Okay, so Karpathy takes this idea, and this is where it gets kind of wild. He starts training RNNs on some pretty unexpected stuff. Like, he uses the essays of, believe it or not, Paul Graham.
Startup wisdom on demand.
Yeah, exactly.
Right.
So, like, is it as good as having a conversation with Paul Graham himself?
Well, not quite.
Okay, good.
But the results are still really interesting.
Yeah, what does it sound like? Like, is it just kind of spitting back his greatest hits, or is there something more to it?
Well, you get those familiar ideas, but there's this element of maybe remixing,
Right.
Like it's taking those core concepts and sort of trying to find new connections. And Karpathy even plays with this idea of temperature to control how creative the RNN gets.
Temperature. So if you crank up the temperature, does it start, like, writing poetry or something?
It's not quite poetry, but yeah, you've got the right idea. A lower temperature means the RNN sticks closely to the patterns it learned from Paul Graham, so it sounds a lot like him. But as you increase the temperature, things get, let's just say, more experimental.
More interesting.
Exactly. And that's what I think is so fascinating about RNNs. They're expressive. They can produce stuff that, while it might not always be perfectly coherent, still has this weird resemblance to the source material. It's kind of uncanny.
So it's not just Paul Graham, though, right? Karpathy goes on this whole, like, training spree, feeding the RNN everything from Shakespeare
Oh, yeah.
to Wikipedia articles.
Right. And what's wild is that the RNN doesn't just pick up on the vocabulary. It starts to capture the style and the structure of whatever you feed it.
No way.
Yeah. So with Shakespeare, you start to see it trying to write in iambic pentameter. Not perfect, but it has that dramatic flair.
Wow. So it's picking up on the rhythm of the language just by analyzing the data.
Exactly. And then when you switch to something like Wikipedia, it's crazy. The RNN learns to mimic the formatting, the headings, even how those links are structured. It's like it understands that there's a specific way to put those Wikipedia articles together.
It's like it's learning the grammar of code, but like without actually understanding code in the way that humans do.
Right.
And this is where things start to get a little mind-bendy for me.
It's about to get even more mind-bending because then Karpathy takes this structured data idea to the next level.
Yeah.
He trains an RNN on a massive amount of latex code.
Wait, hold on. Latex code. That's like the language people use for math, right? So is it trying to write equations now?
Not just random equations. We're talking about latex code that's often so good, so accurate, that it can actually be compiled with very little human intervention.
Hold on. So the RNN is becoming a mathematician now.
Well, it's important to remember that the RNN isn't actually understanding the math in the way that we do.
Okay.
It's more like it's learned the rules for putting together valid mathematical expressions. It's learned the language of math, you could say.
That's still pretty wild, but does it get things wrong? Like, does it ever try to write an equation that's just total nonsense?
Oh, absolutely. There are some great examples of that. Like, It tries to include these diagrams sometimes, and they're more like, I don't know, abstract art than actual math figures.
So close, but no cigar on the diagram front.
Yeah, exactly. Another common mistake is that it sometimes forgets whether it's writing a proof or a lemma, so it ends a block of code with the wrong command.
Yeah.
And these little slip-ups, they actually reveal something really important about RNNs. Even though they're amazing at memorizing these sequences, they can struggle with really long-term dependencies in the data. It's like they have a bit of a short-term memory problem.
Right, so it's like trying to remember something from the very beginning of a really, really long book.
Exactly.
And speaking of long and complex data sets, you mentioned that Carpathy really pushes this to the limit with one final challenge, the Linux source code.
Right. So the Linux kernel, right. Millions of lines of code, this incredibly complex piece of software. It's like he challenged this RNN to become a Linux developer.
Okay, so did it actually work? Did it learn to write C code that actually runs?
Well, runs is maybe a strong word, but the output, it looks shockingly realistic.
Really?
Yeah, you've got correct syntax, the indentation's all there,
Yeah.
even comments sprinkled in, just like you'd see from a human programmer.
So it looks legit.
It really does. At a glance, you'd probably think it was written by a person. But, you know, the details, that's where things get interesting.
So what kind of errors does it make? Like, what does that look like?
You know, it's actually a lot like the mistakes someone who's still learning C would make. So it might forget a variable name that it used earlier, or try to use a variable that hasn't even been defined yet,
Right.
or it might try to return a value from a function that should be void, you know, those kinds of things.
So it's got the building blocks, the syntax of C, but the logic, the bigger picture, that's where it stumbles.
Exactly. And that's a really important thing to remember about RNNs. They can be amazing at mimicking patterns, but that doesn't mean they actually understand what they're doing.
Right, so it's learning the how, but not the why.
Exactly. That's a crucial distinction when we're talking about, you know, the limits of AI and all that.
Yeah.
But you mentioned amusing quirks earlier. You got to tell me, what were some of the funny things it did with the Linux code?
Oh.
Because you can't just, you know, feed an RNN all that code and not have some laughs along the way.
Exactly. So what did it do?
Okay, so this one always cracks me up. It would often start a new file, you know, a new section of code, and it would include this whole long section of the GNU license.
No way. It memorized the legal stuff along with the actual code.
It did. It's those little things that really make RNNs so interesting.
It's like it picked up on the fact that programmers always have to include that legal boilerplate, even though it has no idea what a lawyer is.
Exactly. And that just goes to show the power of these systems. They can find patterns, even when we don't expect them to, even in the most unexpected places.
So we've seen RNNs generating all kinds of stuff, text, and even trying to write math equations. But how do they actually do it? Carpathy tries to give us a little peek behind the curtain, right?
He does, yeah. One way he explains this whole learning process is by showing how the RNN's output changes, you know, as it's training. So he trained one on War and Peace. It was a pretty intense book, and he would sample the output at different points, like taking snapshots of what the RNN was producing as it learned.
So it's like watching a rough draft slowly turn into a finished novel.
That's a great way to put it. At the beginning, it's just gibberish, a jumble of random letters and characters. But then, as it trains, patterns start to emerge. First, you start to see spaces between words.
Okay.
And then punctuation starts to pop up, commas, periods. And finally, it actually begins to spell out short words correctly.
Wow. It's kind of like those stages of language development that we see in children.
Right. And the crazy thing is, none of this is programmed in. It all just emerges from the data itself.
So it's not just mimicking, it's like it's actually figuring out the structure of language on its own. That's wild.
It is. And Carpathy takes us even deeper. He visualizes the activity of individual neurons within the RNN as it processes all this text.
So it's like hooking the RNN up to an MRI and actually watching its brain work in real time. That's incredible.
Right. So you got to remember, what's happening inside an RNN is incredibly complex. Thousands of these neurons firing in these really intricate patterns. But by isolating individual ones, we can start to see how the RNN is representing information internally.
Okay, so are you saying certain neurons might light up when they encounter specific patterns in the data? Like, is that what you mean by visualizing?
Exactly. Carpathy found that some neurons would become specialized for certain features. So, for example, one neuron might consistently fire whenever the RNN came across a URL. So like that neuron became a dedicated URL detector.
And it learned to do that all on its own.
All on its own.
Yeah.
It's the beauty of deep learning. You don't have to program these features in. They just kind of emerge through training.
That's amazing. Were there other examples like that? Other specialized neurons that Karpathy found?
Yeah, another cool one was this neuron that seemed to specialize in markdown syntax, specifically those double square brackets that are used to create links in Wikipedia articles. It would activate when it saw that first opening bracket, and then it would stay active until it found the closing bracket, making sure everything was properly nested.
Wow. So like it's almost as if that neuron is keeping track of the entire structure of the link, making sure it all adds up.
Exactly. It's really highlighting how within this whole vast network of neurons, individual ones can actually develop very, very specific roles. It's wild.
It is wild. Okay, so we've seen all these incredible examples, RNNs that can generate different kinds of text, write code, even tackle those math equations. What's next? Where does this all lead?
Well, what's so exciting to me is that this really does feel like just the beginning, you know?
Yeah, it does.
RNNs are already changing how we interact with tech, like in ways that we're not even aware of.
Yeah.
But there's so much more to come.
Right. But like any new tech, there are always challenges. What are some of the things that that researchers are still trying to figure out when it comes to RNNs?
Well, one big thing is that even though they excel at, memorizing sequences and finding those patterns, they don't always get the big picture.
Right.
Sometimes they get a little lost in the details.
So they might be able to like ace a grammar test, but they'd struggle to actually understand a poem.
Exactly. Another thing is that an RNN's ability to remember is directly tied to how computationally expensive it is. So the more it needs to remember, the more complex it becomes.
Meaning it needs more power, more resources to run.
Exactly. So there's this inherent trade-off. But researchers are coming up with some really cool ways to get around this. One really promising approach is something called attention mechanisms.
Okay. Attention, like how we as humans focus on certain things and kind of tune out the rest.
That's the idea. So think about reading a really good book, right? The rest of the world kind of fades away because you're so focused.
Oh, yeah, totally.
Well, attention mechanisms in RNNs, they're trying to do something similar. Help the RNN focus on what's really important and ignore the distractions.
So instead of trying to remember absolutely everything, it can kind of pick and choose what to pay attention to.
Exactly. And there are a bunch of ways to do this. One approach is what they call soft attention. It's like the RNN is highlighting the important passages in that book you were reading.
Right, right. The stuff that's key to understanding the story.
Exactly. And this helps the RNN make better predictions and just produce better output overall. Then there's something called hard attention, where the RNN actually makes a decision about what's worth paying attention to. It's more like skimming a news article, where you're really just looking for those key facts.
Interesting.
And that can actually make the whole thing more efficient because the RNN isn't wasting time on, the stuff that doesn't matter as much.
Right. So it's like with hard attention, the RNN is actually making a judgment call, almost like a human editor.
That's a really good way to think about it.
This is all so fascinating. We've covered so much ground here. It's really amazing to think about how far we've come from those first, baby steps with these basic language models to these really sophisticated RNNs with attention mechanisms and links to like reinforcement learning.
Yeah, it's been amazing to watch it all unfold.
So what are you most excited about when you think about the future of all of this?
Well, what gets me really excited is that I think we're on the verge of unlocking this whole new level of communication between humans and machines. Like, imagine a world where RNNs actually understand the nuances of language, the way we express emotions, all of it.
It'd change everything, right?
Yeah, we'd have virtual assistants that are actually helpful, educational tools that are tailored to how each person learns best. And it goes beyond language, too. Think about the impact on, let's say, healthcare.
Yeah.
RNNs could be analyzing medical records, identifying those hidden patterns that doctors might miss, helping with diagnoses.
Wow. Or even predicting, potential health risks way before they become a problem.
Precisely. It really is about that unreasonable effectiveness.
It is. It's like mind-blowing potential everywhere you look.
And the truth is, we're only just scratching the surface.
That's both exciting and a little bit terrifying at the same time.
A little bit of both, definitely.
Yeah.
But mostly exciting. I think the best is yet to come.
Well, that about wraps up our deep dive into the incredible world of RNNs. We've seen how they learn, the mind-blowing stuff they can do, and honestly, It feels like the future is wide open.
Definitely wide open.
So as you're going about your day-to-day, just think about it. RNNs are already out there, quietly working behind the scenes. They're shaping your online experience, powering some of your favorite apps. Who knows, maybe you'll be the one to unlock the next big RNN breakthrough. Thanks for joining us for this deep dive, and until next time, keep exploring.